Good morning, students. Today we will have a discussion there on combinational circuit, that is multiplexer. Now, how multiplexer is basically used. Now let us start from the definition what multiplexer is actually. It is a combinational circuit that has 2 raised to power n input lines and a single output line. So what it mean here, it is a circuit that belong to the combinational category, which works on the multi input feature and the single output. So depending upon the multiple inputs, we will have a single output. The another thing that one must take care of in multiplexer is selection lines, because when we are talking about the multi input and single output feature, along with that, the another thing that is required is the selection lines. So these selection lines, they are represented, like in this example, they are represented or they are used with the symbol n. So for n selection lines, we will have possibility of 2 raised to power n input lines. Or in other words, what we can say, the selection of a input line will be taken place with respect to the selection lines. So if in a system there are n selection lines, then we will have in the same system 2 raised to power n input lines. So for n selection lines, we will have 2 raised to power n input lines. For example, if there are 2 selection lines, then we will have 2 raised to power 2 input lines. That is, total will be 4. So depending upon the input, depending upon the selection, basically the input will be connected to the output, or the data input will be connected to the output. So just remember again, multiplexer is a combinational circuit that has some input lines and a single output line. It's a multi-input and single output combinational circuit category. We have, along with the multi inputs and the single output, we have the selection lines. And those selection lines, they are represented, like in this example, we are taking n selection lines here, and for n selection lines, we will have 2 raised to power n input lines. Now, what are its types? The multiplexer is basically available, or we can configure a multiplexer in 2x1 mode, 4x1, 8x1 or 16x1 mode. So when we are talking about a 2x1 multiplexer, now 2x1 mean here, like we can simply use 2x1, or in some representations we use like this, 2:1. So 2x1 or 2:1 mean here we are having two inputs. Let us say they are represented as A0 and the second input A1. So the total inputs are 2. It means that in this example the value of n is 1. So when the value of n is 1, so number of selection lines will be 1, which here in this example is represented with the symbol S0. So 2x1 mean 2 inputs, 1 selection line and 1 output, that is single output, which is represented here with the symbol Y. Similarly, when we talk about the 4x1 multiplexer, the 4x1 multiplexer basically, you can see here, it utilizes 4 inputs, let us say represented as A0, A1, A2 and A3. So 2 raised to power 2, we will have how many input lines? 4, that we are considering in this case. So from this one can simply find out that how many selection lines are needed. So the value of n in this case is 2. So for 4x1 multiplexer we have 2 selection lines. Let us say they are represented as S0 and S1 symbols. And last but not the least, along with 4 inputs, 2 selection lines, we require a output, that is a single output, which is represented here with symbol Y. Similarly, in rest of the versions, if we talk about 8x1 or 16x1, for 8x1 we require 8 inputs and 3 selection lines, and for 16x1 multiplexer we require 4 selection lines and 16 input lines. So depending upon those various multi inputs, we will have a single output, that is Y. Now let us design this 2 by 1 multiplexer. As we already told, we have already there from the previous slide, we know it is a 2 by 1 multiplexer. So it requires two inputs and one selection line. Let us say it is represented with symbol S0. So A0, A1 and the selection line S0 and the output Y. Now, depending upon the selection line, one of these inputs will be connected to the output. Let us learn how it is going to be used. Now, before learning that how this selection will be done for the specific input, let us see the block diagram, which is very crucial here. It shows here a 2 by 1 multiplexer with output Y, the selection line S, like in this example we have represented it with S0, and two inputs A0 and A1. So this is the basic block diagram of an 2 by 1 multiplexer. Now, what is the truth table of this 2 by 1 multiplexer? As we know that the selection of the input will be the output, and this selection of input that depends upon the value of select lines. So in 2 by 1 multiplexer we are having a single select line. Now this select line will offer two possible values, either 0 or 1. So when it is 0, then the output or the input line that will be selected here is A0, and if the value of this select line is 1, then the line A1 is going to be selected. Now, what will be the basic logical expression or the Boolean expression for this circuitry? Now you can see here the single output Y. It is going to be computed with respect to the inputs A0, A1 and the select line S0. So this is the basic formula. Boolean expression or the term Y can be evaluated with this expression there. Now one can simply design this logical or Boolean expression there in the form of a logic circuit. So you can see here, this is S0 bar and A0 plus or with S0 and A1. So these need to be implemented in the form of logic circuit. So you can see this is my first input A0, this is my second input A1. So this is the select line, that is S. So this select line will be used here with the inversion, that is the NOT gate is applied in order to get S bar or S like this. So following the truth table or following the logic expression, the expression is S bar A. So S bar A will be evaluated or will be designed with this NOT and AND combination. Similarly, the second term is SA1. So SA1, it is just implemented by inputting S and A1 to this AND gate. And finally, there is a OR between the term 1 and term 2. So we are using a OR gate there. So this is the basic concept of 2x1 multiplexer. So let us recall it again. We are having two inputs, one selection line and a single output. So depending upon the selection line, these inputs, one of these inputs will be connected to the output. So this is the block diagram. This is the truth table. So this truth table is basically nothing. It is the selection of inputs with respect to the select line values. So here in this example, we are having a single select line that is represented with the S0, or you can simply take it S. So depending upon the value of this S, that either 0 or 1, we will have A0 or A1. And this is the Boolean expression there, logical expression there. Then this logical expression can be designed in the form of a logic circuit here, which here shows the complete utilization of AND, NOT and OR gate. Now, in the same way, what we have learned so far, we can design a 4x1 multiplexer. Now this 4x1 multiplexer requires two select lines. So two select lines mean the value of n is 2. So 2 raised to power 2, we are having 4 input lines. So 2 select lines and 4 input lines. So these 4 input lines, let us say they are represented there in the system from A0, A1, A2 and A3. And 2 select lines, let us say they are represented as S0 and S1, and a single output, that is Y. So just like the previous approach, the inputs will be selected with respect to the values of S0 and S1, that is the select lines. So this is the block diagram of a 4x1 multiplexer. So we are having 4 inputs, we are having 2 select lines, 4 inputs and 2 select lines, and this is the single output. Now what is the truth table? So we are having 2 select lines, S0 and S1. So these S0 and S1 mean there will be 4 combinations of inputs. So those 4 combinations of those selection lines will be 0 0, 0 1, 1 0 and 1 1. So when we talk about this row, when both the selection lines are 0 0, then the input will be selected as A0. Similarly, A1, A2, A3, they all are going to be selected with respect to these values. Now what is the logical expression? So it is again very simple expression there. The expression is, we have here in this example you can see the term y is utilizing all the input variables, that is A0, A1, A2 and A3, and the selection lines, both the selection lines here, that is S0 and S1. So this is the term first, odd with term 2, odd with term 3 and odd with term 4. So this logical expression or the Boolean expression is basically implemented there in the form of logic circuits, or one can simply utilize that Boolean expression in the form of logic circuit. You can see here the first expression is, the first term with respect to this expression is S0, S1 bar and A0. Now you can see here, here it is A0. So it is going to be, you can see here how it is, this term is basically calculated, or how it is basically designed with the help of these gates. So S0 selection line and S1 selection line, they are basically inverted up using NOT gates. So you can see when they are inverted up, they follow this, they are used like this, and they are utilized here as an input to this AND gate. So the output of this one is this complete expression. Similarly, when we talk about the second expression, it is S1 bar, S0 and A1. So you can see here, if we talk about this particular line there, then this particular line, input line, is going to be selected with respect to the term S1, S0 and A1. So we know that if we talk about this AND gate, it gives a implementation of this term. So what are the inputs to this AND gate? You can see here A1 itself. Okay, A1 itself. Then we are having S0 without inversion. You can see here without inversion. Then the third input is S1, that is this S1, and this is basically used here with the inversion part. That is, for inversion we know which gate, NOT gate. So in the same way, rest of the two terms, term third and term fourth, that is going to be designed. And finally we will have this structure. Now in the same way we can have the designing of 8 by 1 and 16 by 1. So let us discuss all those one. What will be the fundamental approach there in 8 by 1? 8 by 1, you can see here. In 8 by 1, we require now 3 selection lines. 3 select lines. Let us say they are represented as S0, S1 and S2. So these 3 select lines, for these 3 select lines we know there will be 2 raised to power 3 input lines. It means 8 input lines. Let us say they are used with A0, A1 and finally A7. So depending upon this, you can see here, depending upon this, let me rewrite it again here, A0, A1, A2 and up to A7. So these will be the input lines. Now if we talk about the block diagram of this 8 by 1, again it is very simple, just like the 2 by 1 and 4 by 1. We will have now 8 by 1. So we will have inputs A0 so on to A7 and 3 select lines. Let us say S0, S1 and 8. 8 input lines here and 3 select lines there, and finally the Y. So this is the block diagram. Block diagram of 8 by 1. Now you can see here, one can even write the truth table of this 8 by 1 multiplexer, just like the 4 by 1 and 2 by 1. If we have to simply write the truth table of 8 by 1, then you can see there in the inputs, third S2 line will be introduced. Like in this example, you can see this is the 4 by 1. 4 by 1, 4 combinations. So if we will include 3 inputs, we will have 8 possibilities. So if we have to write, let us also write, make the truth table of this 8 by 1. So let me write few entries here. It is S3, okay, S2, S1 and S0. Clear? Now what other thing is required? You can even consult that one. We require only single output. Let us say Y. So let us leave this column. Okay. The first combination of the select lines will be 0, 0, 0. So depending upon these, we will have the first output line, that is A0. If 0, 0, 1 combination for the select lines will be used, then we will have A1. Following this one, the last combination will be 1, 1, 1, and it will result to A7. So this is the truth table of 8 by 1 multiplexer. Now what will be the Boolean expression or logical expression for this one? It is again easy to write, just like 4 by 1, one can simply consult. The only thing which is required here is, now we have to introduce the third select line variable, that is S2 here, and along with that we will have to add 4 more inputs lines. Like in this example, A3 is the last input line, but in 8 by 1 the expression will be used here with S2, S1 and S0, and the input lines A0 up to A7. So one can simply write it. If you, it is a very simple one. One can simply write like this. Similarly, if we talk about the logical expression, logic circuit design implementation, one can also make the logic circuit like this. Let me write the Boolean expression. The first term A0. So if I have to write the first term, then it will be S2, S1, S0 plus A0. Now let me read it here so that you can see here. Right. Plus, we can also write rest of the terms. So rest of the terms, they are going to be written in the same way, like we are using here in the 4 by 1 or 2 by 1 multiplexer there. So I hope with this approach one can simply also design 16 by 1 1 multiplexer. In that 16 by 1 multiplexer, we will have 4 selection lines and 16 input lines. So depending upon those 16 input lines, we will have one output line. It's all about the multiplexers. Thank you.